Today, I'm diving into the F2 Ultra from xTool, specifically with regards to its deep cutting capabilities. The F2 Ultra has a 60-watt MOPA fiber laser with a fixed position head. The fixed head makes it extremely fast and accurate, but it isn't ideal for thick materials. That being said, xTool claims that the F2 Ultra can cut through up to 2 millimeters of metal, 23 millimeters of wood, and 20 millimeters of acrylic. Today, I'm going to be testing whether or not those numbers are really possible and what settings are required. I'll also be covering what kind of cutting durations to expect for these depths, and finally, what kind of post-processing the materials need afterwards. The materials that I'll be attempting to cut through in this video are 1mm brass, 1mm stainless steel, 1.5mm brass, 2mm brass, 2mm stainless steel, 6mm hardwood, 24mm hardwood, 3mm acrylic, and 12mm acrylic. If you're already familiar with the xTool software and how material settings are handled, feel free to fast forward to the next timestamp in the video. If not, bear with me as I cover some of the basics. To save you some time, I've already spent quite a lot of time with this machine, but even my testing was fast-tracked by all of the predefined material settings in the software. Now, different machines have different settings for different materials, so these settings are best found by first opening a new file and connecting to your machine. After connection, you can then select a mode and then a material. So for example, we'll choose process on a flat surface and then brass as our material. You can search anything in the search bar, so we'll search brass, and you may notice that you don't get a ton of materials. And that's because the default tab is set to common, and that's based on your preferences or your job history. So we'll switch over to metal, and we'll see a lot more results here. If we switch into list view, you see that most of these items are simply different thicknesses of brass, generic brass, and a bunch of fringe items that you can ignore. We'll choose 1mm brass and apply it to load it into the machine. Now, what you'll notice after choosing a material is that you don't see any settings for things like cutting, scoring, or engraving. First, you have to actually add an object to your canvas, which I'll do here, adding a simple ellipse. And now with that object added and selected, I can choose either score, engrave, or cut. And you'll see that there are now one-click settings for those things. Now, if I switch over to cut, you'll notice something strange, and that is that there are no predefined settings. And from what I can gather is that xTool either doesn't recommend performing that job or it isn't confident in giving an actual suggestion. And you'll see that with a lot of combinations of materials and job types. So I found this kind of strange because they so heavily market cutting brass. And if I switch this over to something like another metal, we'll see the same thing. There's engraving and scoring, but nothing for cut. Now if I switch over to something like wood, let's choose a 6mm basswood and apply that, I do have options for cut. Now, the reason and solution to this is that 60-watt MOPA lasers on highly reflective and conductive materials simply can't get hot enough to cut through the metal. Instead, a pulsing MOPA laser of this wattage prefers to ablate or emboss the material layer by layer until embossing all the way through the material. So let's switch our mode over to emboss, and now you'll see that there's an incise job type, which is exactly what we want to use for cutting through metal. Now let's talk a little bit more about the difference between cutting and incising. If I were to score or cut this letter T, the beam is going to travel along the path of the outside of the T. And that would of course let this letter T fall out from the larger piece of material. If I incise this, the laser is going to treat this more of how an inkjet printer would print this T, and it's going to run along this entire fill, completely eliminating this letter T from your material. So what I want to actually do is run an incise job along the outside of this T. So I need a stroke or a thick line that goes around this shape. Now, xTool Studio actually has an option to do this. It's this little icon in the toolbar here called offset. And I want to offset this externally at least 1 millimeter. Let's go ahead and confirm this, and you'll see now that I have a thick version of the T and then my original T. So what I want to actually do is put the thick version below this in the layers panel. I'm going to select both, and then I'm going to subtract it. And now you'll see if I switch this over to insize, I have thickness to the outside of my letter T. The laser is going to run and fill this area with an insize job, and my original shape is going to fall out of my larger piece of material. Now that we've covered some basic setup and defined some terms, let's dive into some actual cutting. I'm loading a 1mm brass sheet into the machine and heading back over into the software. Now you'll see when I have a generic material loaded, it doesn't show me any settings for incising. And that's because we actually need to indicate the thickness of our material. So I'm going to choose 1mm brass and apply that. You'll now see that we have some incising options here, and it's loading up things like the number of layers, the power, the speed, and more importantly, Z-axis dissension. This is telling the machine to change its focal point in millimeters for every in layers. So with these numbers, the focal point is going to lower 0.01 millimeters for every 10 layers in this 200 layer job. So this is saying that after 200 layers, it's going to lower 2 millimeters. Now that doesn't make very much sense because we're only trying to cut through 1 millimeter. And what this indicates is that the number of layers that these settings have in them vastly overshoot what is actually necessary. And that's because the settings need to make sure that it actually cuts through the material, because if you don't cut all the way through the material, it's really hard to just run the pass again because of the change in focal point. So when you're doing testing at home, the goal is to try to find the closest number of layers to what is actually needed based on your own testing. What I've actually found is that some of these numbers are all over the place depending on the material you choose. For example, if I choose 2mm brass and apply this, you'll see that this changes from 200, 100, 1500 to now 200, 100, 750. So now for 2mm brass, it's still suggesting 200 layers, but it's telling it to move at about half the speed. And I've actually found that 100% power and 750 speed is actually perfect for brass no matter what your thickness is. So what I actually like to do is save these values based on my testing as a saved material. And that's going to let you save the material if you've changed any of these default values to your own preferences. Now, if I change this back to 1 millimeter, since that's what we're cutting, you're going to see that I have some saved settings here, like 1mm brass. And you're going to see that based on my testing, I found that about 75 layers is closer to what you actually need to cut through 1mm of brass. And of course, you're going to see that 100% power, 750 speed, 300 lines per centimeter, and a Z-axis dissension of 0.01 millimeters for every 10 layers. So now that I have my settings pretty refined, I'm going to set up a cut job that's going to cut an arc out of the edge of a piece of material so that we can test this for us all to see. If we go ahead and process this job, you'll see that based on the speed, the number of layers, and the size of the design, that it's estimating 1 minute and 28 seconds. Let's see this in action and see how this actually runs. For each material, I'll show the start of the job in real time so you can get a sense of reality, and then I'll speed the video up for time's sake. This 1mm brass did in fact cut all the way through in just under 75 layers for me, and it took exactly the estimated time. Pretty quick for cutting through 1mm of brass, but let's see how this scales up to a more real-world example. Here I have about a 24 by 24 millimeter object set up with the exact settings that we just tested. Now if I run a process on this, it goes from being about 1.5 minutes to almost 24 minutes. That's quite a large increase, but we are vastly increasing the size of the surface area for this job. Now, because this is a 24-minute job, this is of course sped up quite a bit. But just like my smaller 1mm brass test, this design fell right out of the material after just 75 passes. And you can see that all the negative areas of the design also fell out without any assistance. Now let's look at some of the post-processing for incising metals. The bottom side of the material stays perfectly clean, but a bit of soot builds up on the top surface. I like to use a high grit diamond sanding pad to gently scrub the surface, but you can also use high grit sandpaper or steel wool, and this soot comes right off. Jumping right into 1.5mm brass, you can see that my settings remain the exact same other than my number of passes, which I've increased to 120. With these settings and this design, each pass takes just over 1 second, so 120 passes took just over 2 minutes to incise through 1.5mm of brass. Stepping up to 2mm brass was yet again simply a matter of adding passes. For 2mm of brass, I've increased my passes to 170. At just over 1 second per layer, this job took 2.5 minutes. And again, this duration would vastly increase with larger designs. And you'll notice that with thicker materials like this, you can start to see the effects of the fixed head because the edge is actually cut at an angle. It's definitely something to keep in mind when cutting thicker materials on this machine. The next material that we're going to test is stainless steel. So we're going to stick around in this embossment mode, but change our material over to 1mm stainless steel. So let's go ahead and apply that, and the software will update to this one-click set for incising stainless steel. I have a couple settings saved here, and basically it uses pretty much what they have, but I've changed that the machine lowers by 0.01 millimeters every single layer, not every 10th layer, which is the default. So 125 layers is really what has worked for me. But this really just depends on like the exact piece of metal you get, the exact thickness of it. It could be, 125 layers, 150 layers that you need. So definitely do your own testing. For me, I'm gonna show a video of me using 125 layers. So let's go ahead and load this into the machine and see what we got. These settings resulted in nearly the exact same time per pass as my brass settings, which was about 1 second per pass. So 125 passes took 2 minutes to cut through 1mm of stainless steel. This is almost double the time it took to incise through brass due to its less efficient energy absorption and because it's a much harder metal. Jumping up to 2mm of stainless steel, I simply increased my number of passes. The biggest note here is that doubling the thickness resulted in more than 3 times the number of passes. You can tell from this test sheet that I did mini tests, and these were the settings with the fewest amount of passes. I may be able to dial in these settings in the future, but at the end of the day, the F2 Ultra can absolutely cut through 2mm of stainless steel. All right, so we're going to switch gears over to cutting wood. And so we don't want to actually use the incising embossment for wood. So we're going to go ahead and switch over to processing on a flat surface. And let's choose a wood preset. I'm using 6mm walnut hardwood. So I'm starting with plywood. I can't find a pre-made setting for that. So we'll just start with plywood. It'll be a great place to start. And apply that. And so now we're going to see one-click options for maplewood. Now this is defaulting to scoring, but we actually want to cut, so we're going to switch over to the cutting tab. And I actually like the settings that come with this profile, so a power of 90 and a speed of 30, but we don't need 25 passes. So I've actually saved a couple items here, and the 6mm walnut cutting that I've found only takes 5 passes. So let's use that for our 6mm wood test. When cutting wood, the F2 Ultra actually uses its diode laser. This dual laser technology is one of the coolest features of this machine, but it often results in a burning flame when cutting flammable materials. With a good fume extraction system, this is generally not too much of an issue and still results in a really clean cut, even on 6mm of wood. I didn't have any thicker hardwood, so for my 24mm hardwood test, I'm just stacking up 4 pieces of 6mm material. When getting into materials this thick, focusing on the top surface results in the laser being really out of focus when it gets to the bottom half. For this reason, I actually set my focal point to halfway down, or 12 millimeters down from the top surface, and it resulted in a pretty clean cut all the way through with just a little bit of charring. Again, I simply increased the number of passes with all the other settings unchanged from my 6mm test. But 4xing the thickness required 6 times the passes. This is due to the fixed focal point on such a thick piece of material. All right, now it's time to test acrylic. So we're going to stay on processing on a flat surface, but we'll switch to the black acrylic preset. So let's go ahead and apply that into the machine. It's going to tell us that it's potentially flammable. And I don't have any settings that I've saved here because I actually really like the default settings here. So a power of 90, a speed of 15, and just 2 passes. So let's use that for our acrylic test. Cutting acrylic also uses the diode laser, and I've found that at least with the default settings, the laser melts the material a tiny bit, resulting in some rounded edges and the material sticking to itself. But it ultimately does a great job of cutting through acrylic for a machine that isn't necessarily focused on cutting plastic. This size design took about 1.5 seconds per pass. Similar to my thicker hardwood test, I had to stack some 3mm acrylic sheets to simulate a thick piece of acrylic. I again focused the head halfway down the stack and had to increase the passes a bit more than 4x to get through 4x the thickness of my 3mm test. It took 10 passes to cut through 12mm of opaque acrylic, and I'm pretty happy with how clean this cut was for such a thick piece of plastic. There was a bit of melting from the fixed focal point, but I might be able to dial in the settings to avoid this in the future. Now, xTool does claim that the F2 Ultra can actually cut through 20mm of acrylic, so I doubled my 12mm stack to 24mm and increased the number of passes to 18. Honestly, I think they could safely increase their max specs on this because it cut through the stack without any issues. With just a couple more passes, I think this would have been a perfect cut. I hope this video was helpful if you're deciding on an F2 Ultra but not sure of its thick cutting capabilities, or if you already bought the F2 Ultra and are having trouble dialing in your settings. If you enjoyed this video, I'll be doing a few more deep dives on this machine, so make sure to subscribe to the channel for future updates.